Hello everyone, I am Shuo Jiang. The topic for our machine learning project is image recognition of dogs and cats. We will cover several points in this presentation, including the model we use and the evaluation method we adopt. Let's first look at our introduction and motivation. What's our problem? To distinguish image of cats and dogs, and why we want to do this project, and we decided to work on this topic because the computer has far more intelligence than ever, but it still could not recognize dogs from cats with 100% accuracy, while a 4-year-old child could tell the difference. Our project comes from a Kaggle competition, Dogs vs. Cats Redux. Next, let's talk about the data. Our data is from Kaggle dataset. We take a small portion of Kaggle dataset due to limit of time and computational power. And our setup is to take 2,000 images for training, 800 images for testing. From the data schema, it contains cat and dog images from all angles and all kinds. Thus, the model we trained will be more close to real-world problems. Then comes the algorithm section. We use ConvNet to build our model, and ConvNet is short for Convolutional Neural Network. First, we will introduce neural network. Neural networks are networks formed by a large collection of neurons which reacts to stimuli and generate an activation. Then, what is convolution? Convolution is a mathematical operation and it works very well with image numeric representation. The activation process of ConvNet neuron is like this. First, take convolution of stimuli and weight of ConvNet. Next, use ReLU, an activation function to generate activation. The ReLU was we mentioned in the last slide is a nonlinear activation function. The graph is also shown here. Subsampling is also known as max pooling and downsampling, which we will discuss later. To get an input of an image via a ConvNet, the general process is as follows. First, we conduct convolution and subsampling several times, and then through a fully connected layer, we got the classification output. A typical K-layer ConvNet structure is shown above. It consists of several convolutional blocks, which contains a convolution and subsampling operation, and a fully connected classifier to get the consequence. In ConvNet, a feature map is obtained by repeated application of convolution function across subregions of the input image with a linear filter, adding a bias term and then applying a nonlinear function. This computation is performed in convolution layer. To reduce computation of convolutional of upper levels, max pooling is introduced in ConvNet architecture. Max pooling is a form of nonlinear downsampling. It partitions the input image into a set of non-overlapping rectangles, and for each of the subregion, outputs the maximum value. After max pooling, we then complete a single convolution block. Several convolution blocks are needed before we got the final input for the fully connected layer. And after the process of the fully connected layer, we got the classification output. Here we begin the models section. We first introduce our baseline model. The baseline model has 3 convolutional layers. The loss function we use is binary cross entropy. The accuracy we achieved is 79%. Following the baseline model is a promoted baseline model. The differences between these two models are, first we add 0 padding layer. Next, conv layers increase from 3 layers to 5 layers. Finally, there are more filters, 128 filters in total. We first introduce 0 padding layer. 0 padding layer can be applied before conv layer. Basically, 0 padding can be exactly preserve the spatial size of the input volume, so the output and the input have the same width and height. We also increase the number of layers and filters. A simple idea come up when we decide to promote baseline model. Does more sophisticated model helps? The answer seems intuitively to be yes. However, through our experiments, only properly increasing the number of COM layers and filters can be helpful. Since too many layers and filters will cause overfitting, that lowers the performance of the model. Next is VGG16 model. The term VGG usually refers to a deep convolutional network for object recognition developed. VGG16 has already learned features that are relevant to our cats and versus dogs classification problem. The VGG model we use has 13 COM layers and we also increase the depth of filters from 64 to 412. While the pre-trained weights of VGG16, we fulfilled accuracy with 91%. And this is the assessment section. In the next few slides, we will assess the models, and next we will talk about a few of them. Accuracy increases as epoch grows, as we train in the COMNet, and the loss index drops. While we compare models with different layers, we find COMNet with 5 layers works best. And when we compare the running time of GPU with CPU, we find GPU significantly reduces computational time. With the increase of epoch number from 50 to 80, we didn't find much improvement. These two graphs indicate that VGG16 model has great advantage over our baseline model in terms of accuracy. The final section is our conclusion. To conclude, first of all, we successfully trained a baseline model with accuracy between 75% to 79%. Next, we modified parameters of baseline model and got a better model with 82% accuracy. Finally, the VGG16 model using pre-trained weights achieved accuracy of 91%. In this project, we use Python with Keras to build models, AWS server to help compute since it takes too much time on our desktop. And that's all for this presentation. Thank you.